All right, so number one, we'll evaluate this, and it tells us that x is negative 4. So in the equation, negative 2x, not equation, this is an expression. Negative 2x plus 3, I'm just going to replace that x with that negative 4. So using the order of operations, we'd have to do this negative 2 times negative 4 first, which again, if I did that on my calculator, would come out as 8. So I'd have 8 plus 3. So here's some of the problems that I run into with correcting tests. Is we see something like 8 plus 3, and sometimes just because we want to move fast through it, maybe I'll see 5 on there, okay? All right. I'm just showing you some common stuff here. Sometimes we see that in, not that, I'm sorry, something like 10. Okay, so just in our mind, we're just doing it too fast, okay? Which is why I recommend using the calculator, because, I mean, 10 is pretty close, and the problem was very obvious. It's just we maybe punched in, or we did in our head 7 plus 3, okay? But the answer to this one is 11. So this one, I'm going to have to do it above because I just don't have enough space there. All right, so this is just simplifying this expression. So we do need to distribute the 5, but we also need to distribute the other one. We'll get to that, okay? So we got 5 times 8x, which would give us 40x's, and 5 times 9, which is positive 45. Now the second part here, this is considered a negative 8 because it takes that operation to its left that we're going to distribute into this parentheses. So I really have negative 8 times negative 5x. Now again, in the calculator, you could put negative 8 times negative 5. That should give you a positive 40 right there. Now I've got negative 8 times this 5 right here, which would be negative 40. So this is pretty good so far. I just need to combine my like terms. I've got these 40x's and these 40x's, which when I combine, it gives me 80x's. Now we've got this 45 and this negative 45, which when I combine, I get a positive 5. And that would be as far as we can simplify that. We can't combine the 80x and the 5 because they're not like terms. So we got this 9b plus 7b, but it's minus whatever's in parentheses. Now we can put a phantom 1 there just so we can see what we're distributing. So in actuality, we are distributing a negative 1 into this. So it is distribution, so it's multiplication. Negative 1 times 11b would be negative 11b. And negative 1 times 11 is negative 11. The rest of it stays the same. And now what I can do is combine all my like terms. I've got 9b's, 7b's, and negative 11b's. In terms of b's, again, this is something we could do in the calculator. 9 plus 7 minus 11, I get 5, I think. Awesome. And this negative 11 doesn't have anything to combine with, so it's just going to be minus 11 right there. Here we got negative 27 equals x minus 36. Now this is pretty nice because if I can just drop this x, we'll be in good shape. I just don't want that minus 36 there. So if I add 36 to both sides, and again this negative 27 plus 36 you can do in a calculator, but when we do that we should get a positive 9. Now of course we could check that, again just using a calculator. Negative 27 should equal, we're saying x is 9, minus 36, and 9 minus 36 is negative 27. So that's a true statement, and we can know that the answer is correct. It's just a little way we can check our answer on a test. So. Negative m equals 10. So I just want to point out again that there's a 1 there with that m. It's a negative 1 in this case. It just isn't shown because math people got really lazy over time. So to make this a 1m, I just divide negative 1 by itself, but I got to do it on both sides. Negative 1 divided by negative 1 is 1. Again, there's this phantom 1 here, whether we show it or not. doesn't really matter. But then in the calculator I can do 10 divided by negative 1, which is negative 10. Now we could have looked at this and said, you know what, I'm just going to take the opposite of m, negative m, I'm sorry, which is positive m. But if I take the opposite of that, I can take the opposite of the 10, which is negative 10. Either way works. So on this one, same idea. I got this c, but it's actually negative c. That's the term. So I'm going to drop it there, which means I can't have the 5 with it. I'm just going to zero that out by subtracting 5 from both sides. So that becomes 0, and this is negative c equals 9 minus 5 is 4. And now I can take the opposites of both, make that a positive c, and then a negative 4. Of course, we don't need to show a positive value there. So c equals negative 4. So now we have these multi-step equations. Right here on the left side of that equal sign, we got two x's. We got this negative 1x and then the negative 2x, which as it turns out I can just combine these. So if I had negative 1x and then minus 2 more x's, again that's something I could do in a calculator. That'd give me negative 3x. Now this equals negative 6 still. Of course I want just an x, so I would divide both sides by negative 3, the coefficient of x. These become a 1x. Negative 6 divided by negative 3 is 2. Here we got x over negative 3 equals negative 5 minus negative 2. Now we got this minus negative stuff, which really can be confusing. So if we take the opposite of minus, then we can get rid of the minus the negative stuff. So I'm just going to make this a plus. Now when I combine these, negative 5 plus 2, I should get negative 3. And this equals x over negative 3. So I want to say that we talked about inverse operations, but that was a long time ago, so I may have forgotten. Right here, to get rid of that divide by negative 3, I'm just going to multiply by negative 3. That's the inverse operation here, so that these will cancel out. So I'm left with that x equals negative 3 times negative 3, which is positive 9. So here's a common mistake that I see on these types of problems. Is we got 2 minus 5, that's all good. We got 2 minus 5, which is negative 3. The problem that we run into is we do 5 minus 8 here, which of course is, well, this is still negative 3. We can't do that because of the order of operations. That's 8 times that parentheses. Really, it's negative 8 times that parentheses. So as it turns out, we have to do the distribution first. We can't take the 5 minus 8, so this stuff here is no good, okay? But again, that's a common mistake. Just take your time again and think about your order of operations. So distributing that negative 8 into the parentheses. Negative 8 times x is negative 8x, and then negative 8 times 3 is negative 24. And we have that 5 leading in front. And now I can combine my like terms, the 5 and negative 24, which combine to negative 19. And all this other stuff. Well, now I got to get rid of that negative 19 so that I just have my negative 8x. So I'm going to have to add 19 to both sides. And I got 16 out of that equals, this cancels out into a 0. I got my negative 8x. So to solve for this one finally, we'll divide both sides by negative 8. Kind of ran out of space there, sorry. And again, this is to make this a 1x right here. So I got to put this over here. X equals 16 divided by negative 8. So the fraction line is always division. So you'll want to use division in your calculator. 16 divided by negative 8 is negative 2. These are just algebraic expressions that we're going to write. So we don't have to worry about solving these. We just got to write them. And it may be helpful to remember the words for some of these. So product is multiplication. So we know we're going to have to be multiplying specifically negative 3 and a number, which we can use x for. And that's it for that one. That was just a product. The next one is subtracted, so it's a number, which we'll use x. Again, it doesn't matter if you use x, okay? And we're going to, I should have read the whole thing there. It's subtracted from negative 14. So I got to switch this around. We're going to start with negative 14, and then we're going to subtract x from that. So we got to start with that negative 14, and we're going to take out an x value. Right, an algebraic expression, the quotient. So this is division of a number, so x divided by negative 3. Now, you could have written this as x over negative 3 as well. I'm okay with either one of these. They mean the same thing, so both are good. Linda and Juan went shopping. Linda spent $11 less than Juan. If we let W represent how much Juan spent, write an algebraic expression for how much Linda spent. Well, it said that she spent $11 less than Juan. And of course, this is one of those that's a less than one. So it's going to be a little bit out of order here. It didn't tell us to represent, no, it did. Yeah, W represents Juan. So if Juan spent this much, Linda spent $11 less than that, so we'll have to take $11 off of how much Juan spent. And that would be how much Linda spent. That's all we need to see right there. 4 times the difference of a number and 1 is 8. So this one, we've moved from expressions into equations now. So this was the second part of 2.6. 4 times the difference of a number. So it's 4. And we're going to multiply this by the difference of some number and 1. So this is one of those scenarios where we need to use the parentheses there and distribution. And this is, so that's where the equal sign goes, 8. Now it did tell us to solve this, find the number, so we can distribute the 4. That gives us a 4x minus 4 equals 8. And if we added 4 to both sides, we'd get 4x equals 12. And when we divide both sides by 4, I just kind of ran out of space there. 12 divided by 4 is 3. So x, again, I'm using x. You don't have to. But whatever value you had is 3. 38. A wire 20 centimeters long is cut into 2 pieces. The longer piece is 4 centimeters longer than the shorter piece. Find the length of the shorter piece of wire. So here, we know that we had a 20 centimeter long piece of wire. Now it's been cut into 2 pieces. We got a first piece, which will say is the longest, and the other piece, which is shorter. So we got long and short. And when we add these 2 together, we should get that 20 centimeters that we have. Okay? So this should equal, if we add those 2, 20 centimeters. But up here it said that the longer piece is 4 centimeters longer than the shorter piece. So if I said the short piece was x, then the long piece would be the same as the short piece, but we're going to add 4 centimeters to that stuff. Now again, when we add these, we should get that 20, and this is the equation that we would be using. Now yours could be set up different. You can have x plus 4, it doesn't matter. Of course, we're solving for the short piece, which is x, so once we solve this, we're good. So let's combine these 2 like terms. If I took those 2 x's, then that's what I have, 2 x's. And this would be plus 4 equals 20. And then from here we'd subtract 4 from both sides. giving us 2x equals 16. And some of you don't even need this next step, but it's always good to do it in a calculator. Divide both sides by 2, and x is 8. So the length of the short piece in this case was 8 centimeters. With that, of course, we could figure out the long piece. Just subtract 8 from 20 centimeters, and you got your 12 centimeters. What about 39? A rectangular field is 2 times as long as it is wide. If the perimeter of the field is 450 feet, what is the dimensions of the field? So I'm going to make myself a rectangle right here just so I can see this visually. And I already know that the perimeter is 450 feet. And it says that it's 2 times as long as it is wide. So if I took the width, the length is 2 of the widths, which means that this other length is 2 widths, and then this width is the width. Now when I add all of these, the perimeter is just the outside of this thing. So if I add all of those together, I should get 450, width plus 2 widths, plus the other width, plus the 2 widths, which is the length. Again, that should be 450. So just like we did on that last one, if we combine all these w's, we should get a simplified expression here. So that's a 1w and that's a 1w. 1 plus 2 plus 1 plus 2 should give you 6 w's. And this is equal to 450 feet. So to solve this, we'll divide both sides by 6. And the 6's become a 1 there. So W equals 450 divided by 6. Oh, is that good? Sounds great. 75. Now again, this is a word problem, so we'll just need to label it. That little mark right there, I forget if it's a apostrophe or a hyphen. I don't know what it's called, but that little mark right there indicates that it's feet. Of course, you could just label it in feet either, not 2. Either way, and the width is 75 feet. Now that was just the width. This one wanted the actual dimensions of the field. So if the width is 75 feet, then the length would have to be 2 times that. 2 times 75 feet, which would be 150 feet. Now of course we can check this as well. If I took the length and the width, then I would get 225, and if I multiplied that by 2, I'd get 450. So those are correct. Jason ran 3 times as far as Sean, but together they ran 36 miles. How far did each of them run? So let's just look at what's happening here. We got Jason and Sean. Trying to make that look like it's not a 5. And when we combine these two, right, together they ran 36 miles. Well, Jason ran 3 times as far as Sean. So if we replace Jason with 3 times the amount of how far Sean ran, then we get an expression with an equation with 1 unknown, which we can solve for. That's a 1s, 1 Sean. So combined, 4 Seans ran 36 miles. And if we solve this, we'd divide by 4, and we'd find that Sean ran 36 divided by 4, 9 miles. See, in my mind, I almost said 8 miles because I was going too fast there. Well, if Sean ran 9 miles and Jason ran 3 times that far, that distance, however you want to say it, Jason, then we know that Jason ran 3 times 9, 27 miles. And that's how far each of them ran.